We're going to complete the square to put this into vertex form, but it's going to look a little bit different this time because I have a leading coefficient. I'm still going to start by the same step of isolating the x term, so I'm going to add 2 to both sides, and I have y plus 2 equals 2x squared plus 8x. So the next step here is I have to factor out this leading coefficient. And when I do that, I'm left with x squared plus 4x, and I'm going to figure out what I need to add to complete the square. When I factor out something, really truly I'm dividing it out of both terms. So now I can complete the square. When I complete the square, I'm going to bring down the number in the front. Then I'm going to take half of this number. So half of a positive 4 is a positive 2, and positive 2 squared is 4. Now here's kind of the tricky piece here. The tricky piece here is I didn't really add 4 to the right. Here's what I added. If I distribute that, I get 2x squared. If I distribute that, I get 8x. If I distribute that, how much should I add? Well, I added 8. Now what I do to the right side, I do to the left. So here I have y plus 10 equals the step on the right. So my last step here is I'm going to go ahead and subtract that 10 to isolate. And I have y equals 2 times the quantity x plus 2 squared minus 10. Now I can answer the same questions. My vertex is the opposite of the inside, so negative 2, negative 10. My axis of symmetry, so axis of symmetry is x equals the x value. My domain is all real numbers. My range is going to deal with the y value, which is negative 10. So if I was to plot negative 2, negative 10, and because this leading coefficient right here is positive, it's going to go up. So my range is greater than or equal to negative 10. Let's go ahead and try this process one more time. I have a leading coefficient. So I have to isolate the x terms first, and I'm going to subtract 7 to both sides. So I have y minus 7 equals 2x squared plus 10x. And I'm going to eventually add something else to this. Well, I have to factor out the leading coefficient, so I have to factor out the 2. And when I factor out the 2, I'm left with x squared. I'm going to divide 2 there, so plus 5x. And I'm going to add something to that as well, completing the square. I'm going to take half of this middle term. Well, half is dividing something by 2. So half of that term is 5 halves. And 5 halves squared, I'm going to do that off to the side, is 5 halves times 5 halves, which equals 25 fourths. So this right here is 25 fourths. If you have a nice graphing calculator, if you use parentheses 5 divided by 2 squared, it will give you the answer for you. Alright, so let's keep going. We're not quite finished here. I did not add 25 fourths to the right hand side. If I distribute that, I get 2x. If I distribute that, I get 10x. If I distribute that, I get 25 halves. Again, I can show you that off the side. 25 fourths times 2 over 1. 2 goes into 4 twice. So the top is 25, the bottom is 2. So what I added to the right hand side was 25 halves. So I'm going to add 25 halves to the left hand side. So when I add the left hand side, I get y plus 11 halves. My last step here is I'm going to go ahead and do the opposite, so I'm going to subtract 11 halves to both sides. And when I do that, it cancels there, so I have y equals 2 times the quantity x plus 5 halves squared minus 11 halves. If you would prefer, you can write this with decimals. X plus 2.5 squared minus 5.5. I would take either one of those answers. There's vertex form. From vertex form, I can state that the vertex is the opposite, which is negative 5 halves, comma, negative 11 halves. The axis of symmetry is x equals negative 5 halves. The domain is all real numbers. That's the symbol for all real numbers. And the range is y and the y value. And I'm going to do a simple sketch up here. If I went negative 5 halves, negative 11 halves, I'm somewhere there, and my graph goes up. So it's greater than or equal to.